Turgeon here, bringing you physics from afar. Yes, Turgeon here. You gotta think of this as I'm learning from a person. I know it's a video, but I'm really trying hard, and you gotta try hard too. This is about a video energy conservation document that I've made. So I want you to think of it as I'm trying to complete this document here. Your mindset when you start any class or anything you want to learn, you have to say to yourself, I have to learn this. I'm not sitting here. I got to do stuff. I got to learn this. We just answered question 1. We're going to answer question 2. We're going to answer question 3. You have to have the mentality that I'm going to use my notes. I'm going to take 2 entries and I'm going to use them to do this assignment. Seriously, seriously. You got to like be woke up, like stand up and move around or something. Get yourself worked up, get yourself amped up, get yourself focused. You have to have this mindset. I'm not just sitting here. Put your phone away. You know who you know who you are. Get it out of there. A week from now, emailing me, private messaging me, upset. Oh, my parents are upset because of my grade. My grade. Whoa, it starts here. Forget about your grade. You have the mindset that I'm learning physics right now. You have to listen to me. You can't mute this. You can't fast forward through this. You can pause all you want to and rewind, but you got to listen. And every time, learning physics is all about asking why. If you get a physics question on a quiz or something and you're confused, you got to know why we're doing what we're doing. So ask yourself why. Here we are. We're not just taking an entry. We're doing this. We're doing this. You can use these notes if you get confused. So here's what we have. We have a burger that's being dropped. Don't ask me why, but last year they wanted it to be a burger and not like something boring like a rock or a ball. So 1.4 m, 0.2 kg, you're supposed to know what those are. Ask yourself, Mr. Turgeon knows what those are. Why does Mr. Turgeon know what those are? Why? I know that's the mass because kg means kilograms, which is always mass. I know this is the height because m means a length, and this is a vertical length above the ground, so I know it's height. Why do I know that's height? Because, first of all, when it says energy, I'm thinking about height. Why? Why is that a height? Because meters means a distance. Now, my goal here is I want to compute everything. Remember, you're taking an entry, so you put today's date, you put a title, you put a big circle, and you put the entry, which I think is like 68. Yeah, this is entry 68. For the year that I'm teaching this, it's entry 68. So we're trying to find potential kinetic mechanical, potential kinetic mechanical. You could write P-E-K-E-M-E, P-E-K-E-M-E. To get the potential energy, you don't multiply, you don't divide, you think. How do I get energy? There's a strategy that my teacher's been trying to teach me since September. There's a strategy, and the strategy is, I want you to write this down, use the equation. Write this down. Write the words, use the equations, okay? Write the words, use the equation. Why are we going to use an equation? Because nobody memorizes this stuff. The equation tells you the entire process. The equation has the solution built into it. It has the process. It has the strategy built into it. So we have m for mass, g for the acceleration due to gravity, h is the height, boom, 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 plug them in, 2.8 joules. So I know the potential energy is 2.8 joules. If I went too fast, well, I mean, sorry, but I've done that like 10 times in class. No, I'm just kidding. I have done it 10 times in class, but you can rewind this. I know the kinetic energy is 0. Why? Why is the kinetic energy 0? Because it's not moving yet, right? When you drop something in the very beginning, it's not moving yet. Then it starts to move faster and faster. The mechanical is just the total, so 2.8 plus 0 is 2.8. You're going to do this for number 4. Use the video to do this, okay? You're going to use this entry to do this. Okay. Now watch what I'm going to do here. This is halfway down. How do I know that? Why? Because I can see that this is right in the middle. So I know it's halfway. So I know the height. If you want to plug in the height would not be 1.4, it would be 0.7. If you were to do this calculation, but for this position, it would be 1.7. Sorry, 0.7. And it just turns out, this is just a coincidence, I'm realizing. Potential energy is 1.4 joules. That's just a coincidence, but you can see that the potential is half. So the kinetic energy has to be 1.4 because, okay, here's the really, really most important. I know this is 2.8, so this is 2.8, so this is 2.8. The mechanical energy stays the same the whole time. We don't lose energy. I'll say that again. The mechanical energy stays the same the whole time. So when you do number 4, the most important step is that once you figure out the mechanical energy, it is the same here and here and here and here. This is me helping you with number 4. Mechanical energy is the same here and here and here and here and here because it's the total energy. The total doesn't disappear. The potential will change. The kinetic will change. Speaking of number 4, the potential energy is not 16. 16 is the H, which is not energy. So the answer to this is not 16. You have to do this. This potential energy was not 1.4. The potential energy was 0.2 times 10 times 1.4, which is 2.8. So I got my 2.8. I know the kinetic is 0. I know the mechanical is 2.8. So look, these two add up to 2.8. Now at the bottom, I know all the kinetic energy, all the energy is kinetic. So it has to be 2.8 joules. I know the potential is 0 because the height is 0. Remember, potential is based on height. See that? If you plug in a 0 height, you're going to get 0 potential energy. So you look at that and you're like, why? Why does he know that? I'll say it again. Because there's no height there. This is a law. Pause the video, write all this down, put entry 69, today's date, I think it's the 24th of the year 2021. Law of something, which says the blank energy of an isolated system is constant, but energy may change blank. Let's see, law of total of form. The conservation energy of an isolated, this does not make sense. Law of conservation of form, no. Conservation of energy. The total energy is constant, but the energy might change form. Again, this is me. Like, I'm a person. I'm here. I'm teaching you. Okay, you gotta have that mentality. Like, I'm learning from a person. He's moving his arms around. He's like animated and stuff. Like, you need to not mute videos and like just think like, oh, I go to school, I just sit there. No, you have to have the mindset. Like, I'm learning this. So I went through this. I did this on the video. I told you what to do when you're confused. This is also something I've said many times in September. I just did the law of conservation of energy. And I told you how to do this problem. This is longer, but it's the same thing. Remember, the potential energy here is not 16. The potential energy here is not 12. In physics, you don't just grab numbers. You don't just add stuff up. You don't just grab, I'm thinking I'll multiply 16 times 12 because I don't know what to do. No, that is not acceptable. I'm not going to give you full credit for this assignment if you just say, I don't know. You do what I did here, but with different numbers. You got this, people. This has been Physics from Afar.